Hey, what's up? What's up, everyone? Yeah, I'm still out sick. One more day, and I should be back tomorrow. I'm feeling much better. I love you guys, miss you guys. What I'm gonna do is there's a video lesson that I have for you guys, and there's some notes and practice problems and some equations, all kinds of things for you guys to take. The video is kind of long, so you're really gonna have to lock in. I've stitched the video onto this video, so this is the correct date. In the video, you'll see, I think it's from last January, but don't worry, it is the exact same material that we are covering. Don't worry about the dates that are in the stitch video that is upcoming. I do want to let you know that this is what you're going to end up turning in, which is notes, practice problems, and video lesson for 2/4/2025. Also, don't forget that you needed to finish this ed puzzle. Remember, on ed puzzles, you have to finish the video all the way through, and I think I clipped the video to make it like right after. So we'll address one thing about the ed puzzle. I heard that fifth period had an issue with theirs. So fifth period, and this is for fifth. If you look, fifth period only. I've changed the due date to the 7th. So you have until the end of this week. I know it's a little bit longer. So I would suggest that you either do some of this at home or just do it in a sting session. But again, fifth period, you have until the 7th to get this done. All right, for everyone else, so we'll shift gears out of there. So you guys should see the ed puzzle here. That's for Monday, and then for Tuesday, it should be these notes and practice problems for this video lesson on 2/4. And like it says, turn to a brand new page in your scientific journal, title it Notes and Practice Problems, video lesson 2/4/2025. Write all the notes, all the equations. Everything that are being demonstrated, I'll fix this right now while we're talking, and then try your best to solve and understand all the problems. So pause the video as needed, try and solve, and then if you get lost or you feel like you solved it either case, then play the video and then see if you were right or wrong. It's kind of one of those things where it's self-paced and you really got to try. If you just sit there and copy everything down, you'll learn some, but you won't learn nearly as much. Then once you're done, scan as a PDF and turn that thing in. Solutions as they are, as they are being demonstrated in the video. Boom. Yeah, so this counts almost as much as a journal check, and it will be in the journal section of your grade. I just want to let you know that, so it's worth quite a bit. Other than that, that is everything. Again, watch the rest of this video. Peace, y'all.
Kind and respectful to the people in the classroom. Also, to the sub, make sure to say hi to them, be respectful, say bye to them when you leave, make sure to push in your chair, all of those things, okay? Be respectful to the classroom, make sure if there's trash on the ground, throw all that stuff away, make sure that the tables look nice and neat, you know what I'm saying? Okay, cool. Let's move it along. So, as you take a look at this picture, so just observe this picture on the right for just a moment, okay? And then try to see if you can answer those 3 questions. So again, pause the video and observe this picture right here. There's one right below. And then try and see if you can answer those questions in your mind. Just see what's up. Okay, so how is this picture an example of kinetic energy? Well, we do have the ball moving, and kinetic energy is the energy of motion, right? So what factors affect the energy of the ball? So let's just talk about that. What are the 2 things that could affect the energy of the ball? And most people would say, well, the amount of force that is applied to the ball when it's thrown, right? So then also the mass of the ball, that makes a difference, because if you use a ball, different ones with different masses, right? So a softball versus a baseball, those are very different. Or if you use a different type of ball, like a medicine ball or basketball, like all of those have a different mass. So that would make a difference. And then how fast the ball is traveling, that would affect the energy, right? And then what change can be made to give the ball more energy? Most people would be like, if I apply more force, then that would give it, right? But then also if we change the ball to a different type of ball, that would also be able to affect the energy, the kinetic energy that the ball is moving. As you remember, kinetic energy, right, it has to do with mass and velocity, these 2 things. Okay, cool. So let's keep it moving. This will be in module, so just see it. It is, yes, it is due today. So you got to watch this whole video lesson. So you got to be up in here, pause the video as you need. Do your best to solve all the problems. And again, there's going to be some notes, and then there are going to be some video, also some practice problems. So just make sure to get all that stuff written down, scan it as a PDF, Turn that joker in, no big deal. So what you're going to need to do though, and here we'll go back and read that one time, is make sure that you go to a brand new page. So go to a brand new page, label it notes and practice problems video lesson 122 2024. Make sure to label your new page as that and then write everything in there that you need. Okay, so going forward, I'm just going to tell you right now, we're going to use the Desmos calculator. Again, we're going to use the Desmos calculator. If you have your own scientific calculator, that is going to be okay to use. But if you do not have a scientific calculator, okay, if you don't have one of those, then you are going to use the Desmos calculator, and that one is actually going to be on here. We do have the blue calculators in the class, but they can be a little bit finicky, and I don't necessarily have one for every person all the time, but you will always have your Desmos calculator with you. That way, if you're doing stuff at home, you can always use that as well because it's just on your Chromebook. No, I do not want you using the calculator on your phone. So just to answer that question already, no, don't use the calculator on your phone. Cool. So the Desmos calculator, I'm going to show you where it is located, okay, because I have put it in Canvas for you guys already. So we'll just go ahead and click right on there. Go right into here, into the first period, right? We'll just go in the first period for now. But it is on the Bitmoji Classroom. So I'm just going to scroll down just a bit right there. And it's right here on this first screen. You see how that little finger lights up? Boom, we're going to go and click that. What you should do, okay, this is what I'm telling you should do, is just go ahead and bookmark it. Go ahead and bookmark this calculator. That way you already have it in your bookmarks right here. So for me, I put all of my importance, all the things that I go to all the time, I put them right there. So I order them and I put them right there, okay? And so I would just say make sure to do that, and I think you could just do that like right here. So as you put it up. So anyhow, make sure you have your Desmos calculator. That is the calculator that I want you to use, okay? Just going forward. So I'm going to have that out and I'm ready to rock and roll, okay? Ready to rock and roll right there. All right. Let's go ahead and get back into the lesson, okay? So we'll be using the Desmos calculator throughout this lesson as we keep going back and forth, okay? So here we are right here. And write all of this down. Again, pause the screen, write all of this down, and then see if you can solve this problem here at the bottom. Again, let me go back. Let me see can I go back? Let me see if I can go back. Okay, there we go. So again, right here, write everything down, and I'm just going to talk about it real quick. So speed is equal to distance divided by time, and that's what you see in this formula here. Now, this is the speed formula triangle, and this kind of helps you to understand how it works. So if you wanted to calculate just speed, it would just be distance divided by time. That's just like miles per hour, right? And the per is the line. This is review. Time is equal to distance divided by speed. Okay, so that says time is equal to distance divided by speed. That's how this triangle works. Okay, just like speed is equal to distance divided by time, distance divided by time. See that in the triangle? And then over here, distance is equal to speed times time. So distance is equal to speed times time. That's how this triangle works, so that you can derive all of the formulas directly from that triangle there. Okay, cool. So I'm going to go ahead and, well, I guess I'll keep myself here. So now in a problem down here at the bottom, and again, hopefully you paused and got all this written. Okay, if not, pause right now, get it written. So speed is equal to 100 kilometers per hour, and time is equal to 0.5 hours. So like half an hour. Okay, so that's what it's saying. So then the question would be, since we have speed and time, the third thing is distance. So what is the distance? Well, in order to solve for distance, which one of these formulas would I need? I would need the actual distance formula here. Distance is equal to speed times time. So speed times time. And I'm going to show you how to do it, okay? So we're going to pause right here. Actually, we'll just take the snippet because we're good. Boom. So we're just going to say new, right? I'm going to say new. Can we just say new? Oh, there we go. Bam. And then we're just going to go whoop. Sauce right there. Bam. Okay. So now we're ready to write, and I'll just put myself right here. Again, we're just trying to figure out distance, write the distance. And again, we have, for both of them, we have the speed and we have the time. So then it says distance. So I'm going to go right here. distance is equal to speed times time, right? Cool. So then I'm going to say equal, my speed is 100 kilometers, so I have 100, right, kilometers over 1 hour, okay? So 100 kilometers over 1 hour times time, which is 0.5 hours over 1. Are we good with that formula? So now it's just gonna do some math. So this looks like at the bottom, right? So when we're like canceling, we'll just cancel the hours. Cool. Cancel the hours. Cool. And now we're left with kilometers, right? And that's what we're looking for, distance. So it's 100 times 0.5 and then 1 times 1, okay? So let's just put that in our handy dandy calculator. So 100, right? And it shows it right there. So 100 times 0.5 is equal to 50, okay? So it's equal to 50. All right, totally cool, totally cool. Let's go back to where the heck we was at. Oh, right here. Boom. All right, so then that means, I'm just going to put it up here because it's getting a little bit crowded. 50 kilometers over 1, right? And so that means our distance is equal to 50 kilometers. Not super crazy. So hopefully everyone was cool with that. Hopefully everyone was cool with that. Nothing crazy. Make sure that you show all of your work and you got all that written in there, okay? All right, for sure. Let's go ahead and let me move that and let's go back to this to this jammer right here. Sauce. And then if you see right here, it's the same thing. Distance is equal to 100 kilometers divided by hour, right? And then when you multiply it, boom, it ends up coming out to 50 kilometers. All right. Now, what I want you to do is pause the screen and try and solve these problems below, okay? Pause the screen, try and solve these problems, and then unpause the screen and see if you got it right, okay? All right, so hopefully you have solved the problems or come close. So let's just look at this first one. It says a car travels along a road at a steady speed. So it gives us speed right here, speed of 60 miles per hour. So that's the speed. How far will it travel in 6 hours? Hours is time. And this thing when it says far, that's letting us know, oh, we're looking for distance. So again, we're trying to solve for distance. Very similar to the very first one we did. So we're going to be using this formula right here, right? We're going to be using the distance formula on this first one. So then distance is equal to speed times time. So again, what is our speed? Is 60 miles, right? Per, and that's 1 hour. So over an hour, right? Cool, let me get that. Times, our time is 6 hours. And again, I'm going to put that 6 hours over 1. I'm going to go ahead and cancel the units right there and right there. And then it is 60 times 6. Now, I have memorized that up in my brain. So if you already know what the answer is, it is 360. But I'm going to go ahead and use the calculator to make sure that we're good to go, right? So 60. Oh, wait, I got to go back, sir. 60 times 6. And you see right there, it's 360. So I'll say enter, go down to the next problem. So it's 360, okay? So then we carry that miles unit over. So 360 miles. And then to be technically correct, 1 times 1 is 1. And then that's going to end up being 360 miles, okay? Cool. So let's go ahead and scroll down to the very next one. A train covers a distance, right? So it's giving us distance right here of 480 miles in 8 hours. So we have distance and we have time. So if we have distance and time, we know they're probably going to be asking us for speed because that's the third. If it travels at a constant speed, how fast, that is saying, is it traveling? So it's asking us for speed. So let's just look up there. Speed, right? It's right here. Speed is equal to distance divided by time. Okay. So I'm going to go ahead and get that in here. So here, I'll write that whole thing out. Speed is equal to distance divided by time, right? So it's equal to, our distance is 480, 480 miles. And then our time is 8 hours divided by 8 hours. And again, if you have your times tables memorized, right, you might be able to know what the answer is. If not, hey, it's all to the good. It's all to the good. We're going to go ahead and go 480. And this is one of those ones where I think I know what the answer is, but I'm not certain. 480 divided by, why am I having a hard time? Oh, there's division. It's right there. Divided by 8. It was 8 hours. I think it's 60. Yeah, there we go. The answer is 60 right there. All right, cool. So then, again, 60, right? 60 miles. Oh, and Mr. Farr messed up because our time was 8 hours. So it should be 60 miles per hour. Okay? So that's really how it should be written. A lot of times we write it like this. 60, this is very common practice, miles per hour. But it is 60 miles per is the line, hour. Okay? And it technically is 1 hour because it's per 1 hour. Okay, so that's cool. That's how you calculate for speed. Make sure you have all of those written in there. We've got 2 practice problems. Make sure you got all of your notes. All right, let's go ahead and move forward just a bit. All right, y'all, go ahead and try and solve these 3 problems, okay, exactly the way that I showed you. Okay, try and solve them exactly the way I showed you, and then I will reveal the answer shortly. Okay, so again, pause the video, solve all 3 of these, and then I'll reveal the answers here. Okay, so for this first one, how long would it take a bike rider to travel 36 miles at a constant speed of 9 miles per hour? So when they say how long, then they're trying to calculate for time. So time is equal to distance. So distance here divided by speed, and the speed was 9 miles per hour, it would end up being 4 hours. Okay, a car traveled at 150 miles at a constant speed in 5 hours. How fast or what speed was it traveling? So it's asking us for speed. So speed is distance divided by time. So again, this is the distance divided by time. That gives us 30 miles per hour, right? And then if a bus travels at 5 hours at 40 miles per hour, how far does it travel? This is a distance one. So this is a distance one. So distance is equal to speed times time. And then so our speed is the 40 miles per hour and our time is the 5 hours. And so our distance ends up being 200 miles. Did you get those right? If you did, then you're right on the right track, okay? If you did, you're right on the right track. I would say if you're like, oh, I'm still struggling a little bit, maybe you might want to rewind back and rewatch that portion of the video, just explaining time. But that is how you can use the speed and the speed triangle all together. So we'll go back real quick. And that is how you can use this speed triangle. And I'm going to get myself up out the way. But that's how you can use the speed triangle. And there's 3 different formulas that you can derive from the speed triangle to be able to calculate for speed, for time, or for distance. All right, y'all. Let's move it ahead. Let's move it ahead. Okay. Ooh, I pressed a button. Wrong button. Okay, so you guys should already have this written in your journal. Guess what? I'm going to have you write it in your journal again. Merry Christmas. It is what it is. So how to calculate the average. Remember, the average formula, again, write this in your journal one more time again. I want to refresh it in your brain, is the total sum of all the numbers. And when you see that word sum, that means add all the numbers up. So just like we said before, add all these numbers that are in the set, and then divide by how many items there are in the set. So you would count how many there are, and then that's the number you would divide by. So in this instance, they added them all up. It was 600, right? And then there was 14 items in this set, so they divided by 14. And that's how they got there. So, of course, we're going to do a practice problem. You already know how it is. Blat out. So this is what I need y'all to practice. So go ahead and see if you can add all of this up. And I want you to calculate the high for the day. And remember, the high is the one over here in white. So the high for the week, Saturday to Saturday. Include the other Saturday for the whole week. All of the days they got shown here. Calculate the average high for the temperature in Hilmar from Saturday to Saturday. All of the days. So, okay, so make sure to do that. Again, pause the screen and see if you can get that done. So hopefully you guys did something like this. Hopefully you did something like this. 63, right? That's the high right there. 61 plus 60 plus 60 plus, oh, it's 57 right there, plus 57 plus 61 plus 61 plus 62. Hopefully you did something like that. Then you got to divide it by however many numbers are in this set. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. Now, I'm going to put parentheses on this, and hopefully you remember your order of operations. So remember your order of operations. We got to add all these numbers up first. Then we can go back and say, all right, now we can actually do the dividing by 8. So I'm going to go like that so that way I could see them. Let me see if I could make this happen. Ooh, let me get let's get on. Okay, there we go right there. Okay, bam. That way I can kind of see like what's happening right now. So let me zoom. I need to zoom just a little bit. Boom. Okay, I'm going to move this. Ooh, I can't move it. Let's see if we can move it out my way. Because I need it for my numbers. So let me just memorize the numbers. 63, 61, 60. Those are the first three. Oh, there we go. 60. Ooh. Say enter. 61 plus, what's the next? What's that number? Oh, 63. Let me go back to make sure I got it right. 63 plus 61. Okay. And then I got 60, 60, 57. So plus 60 plus 60 plus 57. I forgot. You could just press the numbers. That would have been way easier for your boy. All right. 61, 61, 62. So we'll say plus 61 plus 61 plus 62. Let me just make sure all my numbers are correct. And this is one thing that's good. And so right here, I already see I got a problem. So I'm going to click right in there. Okay. I'm going to click right in there and just add the plus. That is one cool thing about using this calculator. If you mess up for some reason, you can just verify like, okay, 63, 61, 60, 60, 57, 61, 61, 62. Totally cool. Now, if you really want to get crazy with using this calculator, I can go ahead and add parentheses. So I'm going to add a parenthesis there. And then I'm going to go ahead and say add a parenthesis there. Cool, right? And then I can actually go divide it by 8. And it'll put everything together for me exactly like my problem. Look, blot out, exactly like my problem is. You can input that right into the calculator so that you don't have to do one operation after the other. You can put the parentheses and everything in there, and you can click with your mouse in there. That's what the beauty is of this calculator, and I got my answer right there. 60.65. Is that what y'all got? Is this what y'all got? Is this the answer that you got? 60.25. Now, here's the thing. Do we have any decimal places in temperatures? No. So what we should do is, and I guess I'm going to have to change my color to white. Ooh, so that I can be like, yo, the average temp, right? So the average, ooh, you saw how I did that. That was clean. Average temp, okay, is 60 degrees. And the reason I'm going to say it's 60 is because I need to round to the nearest whole number. So I got to round here. So I need to round right here. And so this number, hey, 5 or more, up to score. 4 or less, let it rest. So I'm going to let it rest at 60, and that's how I got there. Cool? Hopefully we cool. Everybody cool? Everybody cool? Hopefully we cool. Okay, sorry this video is mad long, but obviously it's a lesson that would take the whole period, okay? All right. And then literally we only got one more slide. One more slide, and then you in there. You in there, okay? Cool. So I'm just gonna take the time to walk through the slide. You pause it as you need. Everything on this left-hand side, that's what you need to write down. All of that stuff. This stuff is just some FYI stuff. So I'll get to that when I get to that. But again, everything on that side over there, you need to write all of that down, okay? So make sure you write all of that down. Sorry, I was glancing at the Ravens game. They have 24-10. Oh, this is crazy. All right, so kinetic energy. We wrote down this formula. I just want you to write it down again. I want you to get it in your brain. So kinetic energy's formula is equal to 0.5 times mass times velocity squared. Now, look over here. Look over here where we at. So mass is equal to the mass in kilograms. Write all this down. And velocity is equal to velocity, which is meters divided by seconds, okay? So that's what it is. And so the kinetic energy unit is in joules. Everyone say joules, okay? Joules, cool. And a joule breaks down to 1 kilogram. That's why we have kilograms here. Times meters per second squared. That's what we get this. And then seconds squared, and that's where we get all of these units. So that's the combined unit that it is. That's why the velocity is squared right there. Okay. All right. So here's just an example. I want you to write it down. That way you have an example of a solved problem. Nothing crazy. Okay. So if the mass is 55 kilograms and your velocity is 3.8 meters per second squared, then your kinetic energy would be equal to 0.5, that's the same thing we got in this formula right here, times the mass, which the mass is 55 kilograms, times 3.87 meters per second squared. And that's because the velocity is squared. I'm going to show you how to put that into our Desmos calculator, right? And the awesome part is we can put it in just like it is. So 0.5, right? So that's the first thing we got. And we're just going to press the enter part right there. So we're going to go 0.5 times, and it was 55 kilograms, right? So 55. And again, we're not putting the unit into the calculator, okay? And then 3.87 squared, because that's our velocity, meters per second. So we're going to say multiply times 3.87, right? And then here's the squared right here. Boom. You can put it in just like that, and then you're good to go. And then you got yourself, and then we're just going to say, see what it is, 411.86. Let's see what we got over here, right? And so that would be our answer, 411.86745. But what we're going to do is we're going to round, right? We're going to round to 1 decimal place, okay? 1 decimal place. That's how we're rounding for the whole year. Unless I tell you something different, we round into 1 decimal place. Now with temperature, we had to round to what people use for temperature. But again, we're rounding to 1 decimal place this year. So right here, so we need 411.8. And then, right, then this is what we're saying right here is 6. Is that 5 or more? It is 5 or more, so we'd round up. So it would be 411.9, right? That's exact joules. 411.9 joules. Is that cool for everyone? 411.9 joules. That's how we got that answer, okay? When I'm using a Desmos calculator, you guys really should try and use it as much as possible as you can. This is just an FYI, okay? Kinetic energy, right? You see the formula like this. A lot of times you see the formula like this. Just know that this half is the 0.5 right there. By the way, this is it. And yes, this is a long video. It probably should take you the whole period. Now, make sure to go and scan this thing. Make sure to go, again, like I said, make sure to go scan this thing and get it turned in, okay? You guys already have this assignment. It's already in there. I don't know where it's at right now. But, oh, hold on. Not but this. So we'll scan up. You'll see this assignment in modules, okay? So I haven't input it into modules yet. I will be doing that later on today. But anyway, it'll be in modules because I'm recording this on Saturday, right? It's Saturday. That's why the Ravens game is on. Yeah. So anyway, make sure to get that all of those notes and all of those practice problems, all that stuff we went over, get it all scanned in a PDF, and then go ahead and get it turned in. Make sure everything's labeled properly. All right, y'all. Peace!